Hamdi. Today I will explain about fundamental of distillation column. What is distillation column? Distillation column is one of the most common liquid extraction process and can be carried out in a continuous or batch system. Distillation works by the application and removal of heat to exploit differences in relative volatility. The heat causes components with lower boiling point and higher volatility to be vaporized, leaving less volatile components as liquids. Mixtures with high relative volatilities are easier to separate. This is the function of distillation column. Distillation can be used to separate binary or multi-component mixtures. Many variables such as column pressure, temperature, size and diameter are determined by the properties of the feed and the desired product. Some specialized columns perform other functions such as reactive distillation column, which combine reaction and separation of products into a single unit. There are three types of distillation column. First, batch distillation. Batch distillation is an unsteady operation. It is usually carried out in a batch still to which a column equivalent to a number of equilibrium stages is attached. Alternatively, packings may be used. Second, flash distillation. For flash distillation is a single-stage separation technique. A liquid mixture feed is pumped through a heater to raise the temperature and enthalpy of the mixture. It then flows through a valve and the pressure is reduced, causing the liquid to partially vaporize. Once the mixture enters a big enough volume, the liquid and vapor will separate. Third, the continuous distillation. A liquid mixture of two or more miscible components is continuously fed into the process, physically separated into two or more products by preferentially boiling the more volatile components out of the mixture. For the prototype, our group chose packed distillation column. Packed columns are used for distillation, gas absorption and liquid-liquid extraction. The gas-liquid contact in a packed column is continuous, not stage-wise as in a plate column. The liquid flows down in the column over a packing surface and the vapor. It moves counter-currently up the column. The performance of a packed column is very dependent on the maintenance of good liquid and gas distribution through the packed bag, and this is an important consideration in packed column design. There are many advantages of packed column. One of them are for corrosive liquids, a packed column will usually be cheaper than the equivalent plate column. Packed columns are more suitable for handling foaming systems. Packed columns are not suitable for very low liquid flow rates. The pressure drop can be lower in a packed column than the equivalent plate column. That's all from me. Thank you.
I'm Amanda, and now I'm going to explain on how to calculate stages for distillation column. In order to calculate the stages, we are going to use the graphical method, which is McCabe-Thiele method. In order to perform this method, we have to plot a few data, which are equilibrium curve, feed line and operating lines for the rectifying and stripping sections, which is also known as ROL and SOL. Okay, here are the steps to calculate the stages. For the first one, we have to plot the equilibrium curve or given data, and then plot the 45-degree lines, and also we have to plot the given compositions of feed, bottom, and distillate. From XF and YF, we can draw the Q line, which is also known as the feed line. Next, we have to draw ROL and SOL. Next, for the stages, we start stepping off from the distillate end until the intersection of the two operating lines is passed. After passing the lines, we continue stepping but using the SOL. From here, we can calculate the number of stages and subtract 1 for the reboiler to give the number of theoretical trays or plates. Alright, here are the graphical steps to construct the McCapfill method, which is also the same with the previous one that I have explained. Number 1, the equilibrium curve, and then XF, XB, and XD, Q line, and R minimum, and then ROL and SOL.
everyone. I'm going to explain about the components of distillation column. So firstly, this is a feed. The ethanol will enter into the feed and flow into the tank 1. So before that, this is the heater. The heater will heat up the ethanol and it will goes up into the pack column. So basically, pack column is used for distillation, gas absorption, and also liquid extraction. So the liquid will flow down in column over the packing surface and vapor will move counter-currently up to the column. So the vapor will flow into the cooling tower. So the function of cooling tower, it is use evaporation of water to remove process heat and also to cooling down the working fluid to near the wet bulb air temperature. And lastly, it will flow into the tank 2, which is it will produce water. So thank you.
Hello, today I will explain about gas absorption. What is gas absorption? Gas absorption is a unit operation used in the chemical industry to separate gases by washing or scrubbing a gas mixture with a suitable liquid. Then the purpose of gas absorption. First, gas purification. Removal of air pollutant from exhaust of contaminant from gases that will be further processed. Then, product recovery or production of solution of gases for various purposes. For the successful absorption, the concentration of gas at the top is low and the concentration of liquid at the bottom is high. At top, the inlet is liquid or solvent, the outlet is gas. For the bottom, the inlet is gas or solute, the outlet is liquid.
Factors affecting adsorption. First, cost. Second, viscosity. Third, gas solubility. Then volatility and corrosiveness. As the mechanism of gas absorption, the liquid solvent is fed at the top of absorber by following the gravity, whereas the gas mixture enters from the bottom because of the high pressure at the bottom compared to the top. The absorbed substance is washed out by the solvent and leaves absorber at the bottom as liquid solution. The absorbed gas and solvent will leave at the bottom in form of liquid solution, while unabsorbed carrier gas will leave as gas at the top of the column. The solvent can be generated by a process called disruption.
Okay, I am Anis and I will briefly explain about calculating height for pack absorption column. Firstly, we need to construct the equilibrium line, which the values will be given in question, and operating line. For operating line, we only need x1, y1, and x2 and y2 to construct the operating line and connect the P1 and P2 in a straight line. Next, we need to find the gradient PM1 for trial 1 to get yi1 and xi1 for the first trial using the formula. And next, the value for yi1 and xi1 is used to get the values of 1 minus ym and 1 minus xim by substituting the values into the formula, into the given formula. Next, we need to find PM1 for trial 2 using the same equation. Then we can stop the iteration when the values of xi1 and yi1 is approximately same with the previous values. And for PM2 trial 1, the same equation is used for finding yi2 and xi2. When PM2 for trial 1 and PM1 for trial 2 is almost the same, then we can stop the iteration and the values of yi2 and xi2 can be obtained from the graph. Next, substitute yi2 and xi2 into the formula. Before we calculate the values of that, we need to find all the unknowns. All the unknowns can be calculated by using all these formulas, and then we can find the height.
solvent, insolvent, heat exchanger, condenser, and reboiler. The function of PET column is to increase surface contact area between gas and liquid. Usually, the packing that we use in PET column is ratchet rings.
Now I will explain about the objective of doing gas absorption. The objective of doing gas absorption is to ensure that less harmful gas is released to the environment. For the mechanism of gas absorption, first, the liquid solvent is fed at the top of the PET column, while the gas is fed from the bottom of the PET column. The liquid solvent flow from the top to the bottom is because of the high density of liquid compared to the gas and because of the gravity
while the gas flow from the bottom to the top is because of the high pressure of the bottom compared to the top. The absorbed gas and liquid solvent will leave the bottom as a liquid solution, while the unabsorbed carrier gas will leave the top of the column.